All right, guys. We're going to just complete our overview of vehicle systems. I'm going to complete our overview of vehicle systems today. Then I have a little short questions for you guys at the end of class to kind of go through, just to check for understanding, make sure you guys are seeing some of these concepts. So we talked about body and frame on Wednesday. All right, and then we talked about the four strokes of internal combustion engine. You have your intake stroke, pulls down, brings in air and fuel mixture. You have your compression stroke. You have your power stroke. After the compression stroke, the spark plug goes off. Actually, that explosion, that combustion, pushes the cylinder back down, or pushes the piston back down. It's within the cylinder. All right, pushes the piston back down, and then you have your exhaust stroke, which then gets everything out. All right. The next thing I want to talk about is our computer systems. Most cars nowadays probably have 30 to 50 computers in them, based upon what we're defining a computer as. A computer in our case is going to be defined as anything that can read information from a sensor, then make a decision based upon that information, and then cause another actuator to do something. So you have, in a computer system, you have sensors, computer modules. All right, that's what's actually taking the logic from that sensor and saying, oh, okay, this is happening. Okay, now I got to go do this. And then you have actuators. All right, so those are our three systems of a computer, three components of a computer system. All right, I have a little file to kind of maybe help explain some of this. All right, so in my vehicle, the doors lock automatically. Once I get up to about 3 or 4 or 5 miles per hour, my doors automatically lock. So how this works, this is a very simplified example of how this works, but I have two sensors over here. I have a gear shift sensor and a vehicle speed sensor. All right. And so then I have a computer module here that is reading the input. What is this telling this computer? All right. So once I shift into gear, it sends, hey, I have shifted into gear. Computer modules, all right, cool. That I'm looking for the speed to get up to a certain speed, and then I'm going to lock the doors. All right. So once I shift into gear, it has a yes for that. All right. Still hasn't done anything because it needs 2 yeses for this to happen. And then once my speed gets up to 5 miles per hour, it has a yes for that. Boom, 2 yeses. It sends power to what they call a solenoid, and that locks the door. All right. Same thing on the opposite end. When my speed gets back down to 0 and I shift in to park, the doors unlock. All right. So just because I get back to 0, I could stop at a stop sign, not a big deal. All right. It's not going to unlock my doors. But once I shift it into park, boom, doors come unlocked. So we need sensors, control modules, actuators. All right. Sensors, control modules, and actuators are a broad term. It could be a bunch of different things. All right. It could open up a valve on your vacuum system when you turn on your AC. That could be an actuator too. Just so you guys know, a solenoid. Solenoids are everywhere in your car. All right. And I'm going to fast forward this a little bit so you guys can see. All right. But all a solenoid is wrapping of coil wire. That's all it is. All right. Now it's wrapped like 10,000 times. They have these special wire wrapping machines that can actually do this. It's similar to an electric motor, a brushed electric motor, not a brush. It was a little different. And so when you send power through this coil, you actually create a magnetic field. All right. And you create a pretty strong magnetic field. All right. And so you can see here, once there's current going through here, you create this magnetic field right here. Now, this is a solenoid. Obviously, it's housed in a casing and stuff like that, so a little more control. But you have this huge coil right here. All right. And typically you have a spring, either up here or somehow held up here. And that spring keeps this pushed out. So when there's no power, see how the switch is open? There's no electricity going through this wire. We have power. It's stopped right there and stopped right there. It's not connected. All right. And so this coil right here It's just there's nothing happening. Now, once we close this switch, hopefully it closes here pretty soon. Once that switch closes, boom, you've now created a magnetic field, and it's going to pull that steel or iron bar towards the south end of it. So that just moved it this way. If there's a spring in here, it would have compressed that spring. All right. Now, based on the orientation, that either pulled the lock closed, or maybe it probably could either pull the lock closed. In this case, for my door, if it locked the door by pulling in, um, it would pull some sort of pin or something like that in and lock the door. Or you could have it backwards, where it's normally in this state, and when you hit the button, it opens it up actually, and then pushes a lock closed. All right. It doesn't matter which way it goes. But that's a solenoid. All right. A solenoid is just a ton of copper wire wrapped around, and it's just going to create. Usually, there's a pin in there, and based on whether there's power going through this, it's going to push that pin out or pull that pin in. All right. So that's the actuator part of this. And you can imagine you can use that pin to open up valves. You can use that pin to actually push a lever and lock a door. Um, you can use it any way you want, but that's the motion of a solenoid. All right, we'll keep going down our list. Fuel systems. All right, obviously super important. They're the ones. So you have typically in a car. I have a little quick image up here. All right, you have your gas tank back here. You have a fuel pump usually with inside your gas tank, um, and then somewhere along the line here you'll have a fuel filter. On a well-maintained fuel system, the fuel filter should be the only thing you have to actually change out at a certain amount of time. Injectors go bad. I mean, everything goes bad. But so this is delivering air, this is delivering fuel into our motor. This is a common time with fuel injectors. Yes, there are carburetors. Diesel has a separate system too, but we'll mainly just focus on this one because it's the most common. And that's actually going to be pushing on the intake stroke. That fuel injector is going to open. It's going to spray gas into your cylinder, and as you draw in air, that creates that intake stroke. So those work in concert with your internal combustion engine. Electrical system. So this is where it gets a little bit in the weeds. What's the difference between a computer system and an electrical system? They sound like they're the exact same thing, or they could potentially be. We're going to try and differentiate the two, but they are very similar. All right. And a lot of these things, like you have an electrical system within your fuel system, because you have sensors in there that are reading things to make sure you're piping in the right amount of gas based upon the throttle and how hard you're pressing on the gas pedal. So yes, there is some crossover. So I'm going to try and keep them separated until we kind of get some dive in deeper with this stuff. But obviously, your ignition system that starts your car. All right, charging system is big on the electrical system. All right, that's your alternator, making sure everything on there is working. Because remember, your battery starts your car. Once you're up and running, your alternator is powering everything else in your car and charging your battery back up. It's a big stress on the battery to start that car because you're bringing in tons of amps. All right. So the alternator is part of the electrical system. It's a big part of the electrical system, and then of course lights and stuff like that. All right, pretty straightforward. We'll get into this. I think we might hit this earlier on because we could explain it a little better over the internet and stuff like that. So we'll go with that. We have cooling and lubrication systems. All right, water pump and coolant. So obviously you're creating your internal combustion engine, right? You're having an explosion every 4 strokes, right? You're having an explosion. Well, that's going to create a ton of heat. Now we have systems in our, your cast iron, your block of your motor, that big cast iron piece of metal that your cylinder, bores in there and everything like that. That could withstand a lot of heat on its own, but we want to keep it nice and cool, so it doesn't, because heat causes warping, causes cracking. It can even blow out a hole in the side of your engine. So you have inside your motor, you have these things called water jackets. Um, and so let's see, some of these ports, I'm sure. So is what we do, we just pipe coolant through your motor. Let's see if we can get an image. This might work. you can pipe coolant. So, all right, we have our thermostat that's regulating the temperature, so we know how much coolant, bring in more. But then in our motor, this is the actual block of our motor, we have these water jackets, and we're pumping coolant through your motor through these water jackets. And then is what happens once it gets pumped through your motor, it gets back into your radiator. All right, your radiator. You have your engine fan right here that blows, blows air on that radiator, and then your radiator, it has to go through all these little um, small little holes and stuff like that, makes its way through the radiator relatively slowly, and it spreads everything out really thin. All right, as we could imagine, if I had water in this water bottle, all right, and I had the same amount of water. Let's say I had boiling water in this water bottle, all right, full, all right, and I took the same amount of boiling water and I poured it on the ground, all right, we would realize that the water on the ground, because it's all spread out, has a higher surface area. It's going to cool down faster than the water in this thing, and that's essentially what your radiator is doing. It's spreading out all that coolant and water mixture, all right, as it's kind of coming back down to the bottom, so it can get pumped back into the motor. All right, it's spreading all of that out. So as it comes down, along with the fan, and you have a grill too, it's blowing air on there. That gives you a nice cool. It cools down the water and coolant, so it can go back into the engine. It is a closed system, all right, and so if you're leaking coolant or anything like that, that's a serious concern. All right, overheating of vehicles, is extremely common issue with the maintenance of a vehicle. So coolant lubrication is the oil and stuff like that. The oil actually also helps cool the engine, um, but we'll get into that. All right, the lubrication of everything. We'll talk about that when we get more into the piston and the piston rings, how they carry oil up and keep everything lubricated in there. So we'll get into that. The drivetrain system. All right. So this is separate from the engine, although it works with the engine. The engine provides the power. The drivetrain system delivers that power to the wheels. All right. Um, and so it has a couple components of the drivetrain system that are pretty cool. Let's see if I can just draw something out real quick here. Um, so let's say this is my motor, right? And then I have my drive axle. I have my I have uh, my my drive axle right here. Hold on, sorry, I gotta get this thing set up. Um, all right. Um, uh, so one of the things, you have your engine's going this way. All right, it's sending down your drive shaft right here to your rear axles. All right, and so you have what's called back here. You have a thing called a differential. The differential does a couple things. The first thing is this is spinning perpendicular to this line. All right, so you're coming in like this, and you want to make sure that since this is spinning like this, you want your wheels to spin perpendicular to that. And so it has a unique gearing system that allows motion to come this way to go back out at a 90-degree angle. All right, so it sends linear motion in one direction into a perpendicular direction to your wheels. The next thing it does, it actually allows these two wheels to spin at different speeds. All right, and this is very important. Um, think about it like this. All right, this is my rear axle, right? I'm going straight down the road. If I'm going perfectly straight, these wheels are spinning at the same speed. But if I was to rotate, if I was to make, let's say I make a left turn, all right? I'm making a left turn right. Come on, rotate with me. All right, making a left turn right here. Well, we know if I'm making a turn like that, my outside wheel is actually going to be traveling more than my inside wheel. This has to go farther. All right. This is a smaller turn right here for this wheel right here. So this wheel has to spin faster. And our rear differential, which would be a little, something right around here. All right. Our rear differential actually has some unique gearing that we'll get into later that allows this wheel to spin faster than this wheel. And then the opposite, if we were making a left turn, it would allow my outside wheel, my right wheel, to spin faster than my inside wheel, left wheel. So that's the drivetrain, and that differential is a very important part of that. All right, you have your drive shaft and your differential kind of work together to make those two things happen. All right, suspension, steering, and brakes. So one thing about brakes is probably the primary safety feature of your vehicle, right? And I know at my previous job, kids would get a new car, a new to them car, right? They get on Craigslist and buy a car. And the first thing they'd always want to do is build like some subwoofer, sound system box, all that kind of stuff. And those are great. I built dozens and dozens of those over the years. But the thing I would always make them do, you get a car off Craigslist or you get a used car, the first thing you need to do is the brakes. All right. You can have a wonderful sounding system. If you can't stop your car, that's not going to be sounding good for very long. All right. So anytime you get a new car, first thing I do is at the very least, inspect the brakes. But usually I just swap them out when I get a new car. It just makes me a little more confident. And I know I'm driving safely. I'm make it to work. Steering obviously turns the car, and suspension. Now up here in this area, suspension I feel is super important. We live on a lot of single lane roads, bumpy roads. We're constantly dipping and diving and we're not driving in the city where it's nice and flat and everything's pretty straightforward. So suspensions around here I feel are very important as well. And then, of course, we have accessory and safety systems, air conditioning, sound systems, seat belts, airbags, those types of things. So that's pretty quick. Just a general overview of the kind of stuff we're going to be looking at, so you guys have a basic idea when we get to it. If you can now, guys, go ahead and go back over to Google Classroom. There's a little short, 5, 6, 7 question thing just to make sure you guys are understanding it. And if you have any questions, let me know. The little survey or a questionnaire. If you don't take it, you can take it multiple times. If you don't get 100% the first time, take it again. All right, I don't care. If you're taking it again, just think about, okay, what did I say wrong? Oh, okay, so it's this one. There, you just learned something. So I'm not opposed to you guys taking it multiple times. All right, there's no point in you failing it and never learning, and I keep moving forward. So at least keep taking it multiple times. I want to see everyone get 100% on that. And we will reconvene on Wednesday. So no homework over the weekend, but best of luck to you guys. All right, take care.